A very good day to all. I again hope all to be well. So now, gents, I would like us to continue with functions, and I would like us to do so by going through the transformations. So now remember that our functions can undergo various transformations. So now today, I want us to just look at the translation as well as the reflection. So now the functions that I would like us to look at would be the hyperbola. So that would be the hyperbolous general form over there. I would also like us to look at the quadratic or the parabola with its own general form over there. So now this general form in itself for the quadratic would be the turning point form, or rather the vertex form. So now that's how we can then conduct the various transformations taking place. So now I would also like us to go through the exponential function as well with its general formula over there. So now, gents, the translation just talks about you moving the actual function either to the left or to the right by however units, as well as up or down by however many units. So now, whenever you translate the function to the right, you are essentially you're actually subtracting from the p-value. So that would be this p-value over here. So let me just mark it for all the functions. So now that p-value over there is essentially responsible for either left or right translation. So now if you intend on translating the function to the right, then the p-value will be negative. So that in itself would be counterintuitive. So the p-value would be negative if you intend on translating the function to the right. The p-value would be positive if you intend on translating the function to the left. So that would be either left or right. So now when you translate the function either up or down, you would then concentrate on the q value. So that would be this q value over here. So that would be the q values. So now how you do so, to move the function upwards or to translate the function upward, the q value has to be positive. So that would be a greater than 0 q value. And for you to translate the function downward, the q value has to be negative. So that would be vice versa in terms of either the horizontal. So that would be, let me just mark this a bit. So this in itself would be the horizontal, and this over here would be the vertical. So very, very important. So now remember that whenever you translate by however many units that have been spoken of. So now let's also go through some reflection. So now this would be another way in which you can transform your function. So now you can transform your function or reflect it for this case by either reflecting it about the y-axis. So now what you do is you essentially just have a negative where the x value would be. So now what this means is if you have the point 2:3 over there, a reflection about the y-axis only changes the sign of the x value. So it means that the reflected function would have a negative x value. So now what this also means in terms of the function itself is that the function will then, you would essentially just have that negative over there. So each would have a negative, each would have a negative over there. So that's you having reflected the function about the y-axis. We can also do the same thing with the x-axis. So that would be reflection about the x-axis changes the sign of the y value. So it means that the y itself, so I'll just maybe make use of another color here. So it means that the y itself has to be negative. So you would essentially just have it negative there if you are reflecting about the x-axis. So now, gents, that's what I wanted to share with you guys with regards to the function transformation. I want us to also go through some questions that I've prepared. So I'll just move on to the next page for them. So now it says given f of x, which happens to be quadratic, and g of x, which happens to be hyperbola. So now 1.1 wants us to determine, so I'll just maybe make use of another color here, wants us to determine the equation of h. So that would be what you will transform it to. If h is the reflection, so h is being reflected about the x-axis, and then translated 2 units to the left. So not only is it being reflected about the x-axis, but it's also being translated 2 units to the left. They also want us to leave the answer in the form, that form over there, which is the turning point form. So now let's go over to the next page for us to be able to do so. So we'll just maybe move on to the next page there. So we have the f of x, which equals x squared minus 7x plus 10. So now the first thing to do would be to convert the function, so the function itself has to be converted to the turning point form. Remember how we do so? We would need to take the coefficient of the x over there. We would firstly half it, then square it. Once we've done so, this would then just give us a 49 divided by 4, which we can add both sides, which we can add as well as subtract. So now what this will then give us, let me just change this to that color. So this would then give us an x squared minus 7x plus a 49 divided by 4. So this should be 4 over there. Minus a 49 divided by 4 plus the 10. So now what you've done here is you have essentially just added 0. So you haven't changed anything. So you can then take this portion over here. You can then make a perfect square with it. So the perfect square there would be x minus, so you would take this portion here. So that would be the inside there. So that's 7 divided by 2 squared. Then you would then just simplify what you are left there. So this in itself will just give us a negative 9 divided by 4. So this in itself would be what f of x would be in the turning point form. So now just going back to the question wanted us to reflect about the x-axis. So when we do so, when we reflect about the x-axis, we would need to make the y negative. So now that in itself would be negative. We can then multiply out by that negative. So it means that h of x would then be negative x minus 7 divided by 2 squared plus 9 divided by 4. So what we've done is, since this y here was negative, we just multiplied throughout by that negative. We were also asked to translate the function itself 2 units to the left. So remember that translating to the left talks about the p. So that would be us having to add 2 units to the p. So this in itself would just be negative x minus 7 divided by 2 plus 2 squared plus 9 divided by 4, which then equals negative x minus 3 divided by 2. So that would be the 7 divided by 2 plus the 2, and then that's squared plus 9 divided by 4. So now that in itself would be the complete transformed function, which is what 1.1 wanted us to do. So now let's move on to 1.2, which wants us to describe the transformation from g of x. So that would be from g of x over there to j of x, which would be 2 divided by x minus 4 plus 2. So now checking the negative 3. So the function went from negative 3 over there. So that negative 3 to negative 4. So it means that p in itself was equal, or rather equal to negative 1. So negative 1 was subtracted, or rather 1 unit was subtracted from it. So now remember that that in itself would be a negative p. So that would be a negative p over there, which means that the function was translated 1 unit to the right. So that would be 1 unit to the right. The q in itself is different as well. So that's a plus 4, from a plus 4 to a plus 2. So 2 units were subtracted. So it means that the q in itself would be less than 0, which then means that the function itself was moved downward by 2 units. So we can say that the 1 unit, so that would be 2 units downward. So the function was shifted. So that would be shifted 2 units downward. So that would be how we would describe the transformation that has taken place. So now, gentlemen, that's what I wanted to share with you today. Please do go over the vid so that you may be able to properly attempt the work that does follow. A good day to all.